G'day students, hope you're all doing well. Welcome to the first lesson of our new topic, which is going to be on number patterns and recursion. Now, I hope you guys will follow through with this lesson and write some notes. Please make sure you write notes and annotate using the notes provided to you by the teacher, and that you're paying attention to this very first lesson, as I assume not many of you would have done much of this topic in the previous years or in your previous schools. So please make sure you're paying attention. All right, so this is our first lesson for the new topic. And in this first lesson, we're going to be covering what we call your arithmetic sequences. Okay, arithmetic sequences. And most of what we're going to do in this lesson is understanding how to generate terms in an arithmetic sequence. Now, a lot of big words, I know, but bear with me. Hopefully you'll be able to understand what this whole new topic encompasses. Now, before we get into the nitty-gritty of it, just want to give you an overview of what this topic will look like, because you may find some common ground or similarities in another topic that you would have learnt previously, I hope, on financial arithmetic or financial maths. Okay, so there are similarities between number patterns, recursion, and arithmetic sequences, which is what we're going to learn about with your financial arithmetic. We can see arithmetic sequences will have relevance to it, but what we're going to look at is obviously today your arithmetic sequences and understanding what a recurrence relation is, and then we're going to see the relevance of it to finance. So existing finance words will definitely come up in this topic, so bear those in mind, like principal, rate, time, those sort of things will occur here. And most of it will come into practice when we do some financial arithmetic. Now, there is one thing missing here that I'd like you guys to write down in the bottom arrow, which is going to be on geometric sequences. So we have already a few words that we're learning about, or that are new. So that'll be the sort of last thing we'll learn in this topic. So there'll be about 4 to 5 lessons, I would say, with this topic. All right, let's get into it. So our learning intention for today is to understand the concept of arithmetic sequences. So when we talk about concept, we're talking about what is the idea behind what is an arithmetic sequence. Okay, so main ideas, maybe some elements of what an arithmetic sequence is. Okay, so keyword there as well is the word sequence. Okay, we'll get into what that means shortly. And as our success criteria, we are hoping that you'll be able to identify, identify what is an arithmetic sequence. Okay, so know basically what it looks like and be able to calculate and apply another keyword here we're going to learn about, the common difference. Okay, it's another key keyword that you'll have to learn for this session. So identify your arithmetic sequence and able to calculate and apply your common difference. Okay, let's get into it. So, basic definitions that you might need to know. When it comes to this topic, there a lot of the times what you'll find is there are patterns. So, we're going to look at number patterns. Okay, so if I was to condense and maybe really simplify what this topic is about, it's about looking at number patterns, looking at different things happening within a set of numbers. Maybe a number might be adding by the same amount, or it could be dividing by the same number, or it could be minusing, it could be multiplying, okay? But what we're going to try and look at is identifying different patterns within a set of numbers, okay? So when we talk about arithmetic sequences, okay, what that refers to is it's a list of numbers. So again, with recursion and number patterns, it's always some sort of list of numbers where the next term, so when we're talking about term, another word for term, you can say next number, or you can actually just say number for it. So when I say term, I might say term number 1. So you're telling me the number 1, or what is the first number? Term number 2 is the second number. Term number 3, third number, so on and so forth. Okay, so this is saying it's a list of numbers, or an arithmetic sequence is a set of numbers or a list of numbers where the next number is generated, which is made by, so generated meaning made by, you're either adding or subtracting by the current term with the same number. So saying is the next number, okay, in an arithmetic sequence. To get it, you're either adding or subtracting by the same number. Okay, so you're adding or subtracting by the same number to get the next number. So here's an example. Let's look at this number pattern. So the first term, so you can see that T1 means term number 1, so that means first number. T2 is second number, T3, T4, T5, so on and so forth. But if you look at this sequence of numbers, look at the pattern of it, okay? We can see first number is 5, second number is 12, third number is 19. What is happening to it? I've already put it in brackets there, but obviously you can see, okay, that it's adding 7 each time. So that means to get the next term, we add 7. Okay, adding by 7. Look at the other set of numbers here. So this other number set, we start with 87 for T1, 84 for T2, and then T3 is 81. So you can see here that instead of adding, this time it's subtracting by 3. Okay, so it's going down by 3. Okay, so what we're seeing here is this is what we would call an arithmetic sequence, okay? Because with arithmetic sequences, you can think of it as adding or subtracting by the same number, okay? You could simplify it to that if you wanted to. It's a lot of words here, but yeah, I would say for an arithmetic sequence, you're either adding or you are subtracting by the same number. Now, it's not always a whole number. It could be a decimal number as well, okay? So that might change depending on the sequence of numbers. Now, the common difference is another keyword we need to learn about. So your common difference, okay, is the number that you're either adding or subtracting, okay, to get the next term in your arithmetic sequence. So you could say that the common difference is basically, if we go back to the previous examples, it's these numbers. There's your common difference, -3, okay? And then for this sequence here, the common difference is 7, okay? There is your common difference. There is also your common difference. So it's the number that you're either minusing or adding by. Okay, so if I look at this sequence here, I see that the first number is 2, the second number is 7, the third number is 12. So what's it going up by? It's going up by +5. Okay, so I look at all the numbers. It's increasing by +5. Therefore, the common difference, okay, is going to be +5. Okay, it's adding by 5. Let's look at this other sequence. Okay, I can see first number is 9, T1. Second number is 5, that's T2. T3 is 1, T4 is -3, T5 -7. So it's going down by 4, so -4. So it's minusing 4 each time. Remember, a arithmetic sequence, you're either adding or subtracting by the same number. Okay, so the common difference here is going to be -4. Okay, because it's minusing by 4 each time. Now, keep in mind that with an arithmetic sequence, the common difference has to be the same each time. So if you ever come across a sequence where, for example, right, let's just say the numbers here are different, and then randomly this becomes +2, this is not an arithmetic sequence anymore, okay, because the common difference has changed. It has to be the same common difference each time. So just keep that in mind. Okay, let's go to the next part. So with the common difference, okay, with any sequence that you work with, you're going to need to know how to find your common difference. So you need to be able to figure it out, basically, calculate it. Now, you can actually just look at a sequence, okay, and calculate in your head how much it's going up or down by, but there is a specific formula which we will learn about here. So to calculate your common difference in an arithmetic sequence, so remember with arithmetic sequence, it's going up and down by the same amount, adding and subtracting by the same amount, and the common difference relates to the arithmetic sequence, okay? With other sequences, there's different types of differences, but for now, let's just focus on common difference and arithmetic sequence. So how do we calculate them from an arithmetic sequence? We do this by choosing any term and then subtract the previous term. So Here is the formula for it. If you want, please make sure to highlight it. To calculate the common difference, it's any number or any term minus the previous term. So any number minus the one before it. For example, let's calculate the common difference in this following sequence. So as you know, Mr. Torrio likes to use formulas and write them down properly. So I'm going to go in depth with actually writing every step for those that need it so that you all understand it. So firstly, let's write down the rule. So the common difference rule is any term minus the previous term. I'll eventually write this shorthand because it's a lot to write, but for now, and for everybody's sake, please make sure that you're copying this as well, okay, that you know and understand how to use the rule. So any term minus previous term, right? So what you can do, according to this rule, is you can pick any term you like and just take away the one before it. So I might, for example, go T4, take away T3. So I'm going to go T4, and the term before that will always be T3. So T4 minus T3. Therefore, your common difference from there for now is going to be T4 is, if you can look at T4, it's 18. So 18. And T3 is 14. So therefore, the common difference is 4. 18 minus 14 is 4. Straightforward. You can actually use any term you like, and you'll always come across, well, if it is a proper arithmetic sequence, the common difference will always be the same. So let's try another one. Let's try, for example, T2. Take away the one before it would be T1. So that would be 10. Okay, take away 6. And you can see 10 minus 6 is 4. Let's try another one. One more. Okay, you can go with T5, take away T4. So you can go T5, take away T4. That would be 22, take away 18. And like I said, if it's a proper common difference, arithmetic sequence, the common difference will always be the same. And you can use any term, but you got to minus it with the previous term. So that's how we use this formula in finding the common difference in a arithmetic sequence. So remember that common difference is the number that you're adding or subtracting by. Let's do these examples. Find the common difference for the number of blocks in each pattern. So looking at these blocks, let's count how many blocks there are in each pattern. And actually, before I even do that, it's probably a good idea to also label them. So when I say label, as in putting the term numbers. So this is the first lot of blocks, so we're going to call it T1. Actually, no. I don't have to use T. Let's use P. I'm using P because in the next question it uses pattern. So let's just call this P number 1, pattern 1. This can be P2, pattern number 2, and P3, pattern number 3. All right, so in this example, let's find the common difference for the number of blocks. Now, again, I just used P because it uses P in the next question, but technically you can actually use any letter as long as you understand, okay, that these little numbers represent what number they are basically. Okay, so pattern number 1, okay, I can see has 5 blocks. Okay, pattern number 2 has 9 blocks, and pattern number 3 will have 13 blocks. Okay, I'm just counting them. Okay, you can actually put them in as well. That's got 5. This has 9, and this has 13. Okay, that's the number of blocks in each one. Probably a good idea when you do these questions, especially if there's an image involved, that you just write down how much there is for each one. So P1 has 5, P2 has 9, and then P3 has 13. Okay, that makes it easier to actually look at the information. So the question here is we need to find the common difference. So remember the rule. The common difference is any term minus the previous term. Okay, so any minus the previous, so I can pick any term from this sequence. I might go with P2, take away P1. Okay, so P2, take away P1, which will be 9, take away 5. Oops. 9, take away the 5. So 9 minus the 5. Therefore, the common difference is 4. Now, I can test this as well, okay, and looking at the I can use P3. Okay, so I can try and use P3 if I want. Minus P2. Okay, so that'll be 13 take away 9, which will be 4. So the common difference, again, is the same. Therefore, that would be your common difference. Question B, how many blocks then will be needed to produce the 6th pattern? Okay, so we know that each time you're adding the same amount here, it's a arithmetic sequence, and we can see here that we're adding by 4. So the common difference is plus 4, plus 4, plus 4, and it tells us what pattern 4 and 5 are. So therefore pattern 6 is going to be plus 4. Okay, so you're going to add 4. So that means pattern 6, okay, whatever pattern 6 is going to be whatever pattern 5 is. So you can see pattern 5 is 21, P5, plus whatever the common difference was, which is 4. So therefore, pattern number 6 should be 21 plus 4, which equals 25. Now you can tell me and say, look, sir, can't you just like add 4 to that and then write this as your answer? You technically can, right? But in year 11, they do expect you to show working out like this. So I'll continue to do it like this so that you guys get used to the type of notation we use in order to actually get full marks when you do these questions. Okay, you have to show working out. I know it's simple, okay, but you must show your working out with these questions. All right, let's go to the next part. So find out which of these sequences is arithmetic. Give the common difference for each sequence that is going to be arithmetic. So figure out which is arithmetic. Remember, arithmetic means you're adding or you're subtracting by the same amount each time. Okay, and then from there we need to find as well the common difference for the ones that'll be arithmetic. Okay, so what we'll do is we'll just look at these examples, okay, and we'll determine which ones are going to be arithmetic, and then we'll write down a common difference. But I won't show the full working out for determining which ones are arithmetic. Okay, you can just for now recognize which ones are, because remember, arithmetic, adding and subtracting by the same amount. So I can see for the first one it goes 3, then 1, then -1, -3, -5. So if I was to test this, I can see 3 to 1 is -2, 1 to -1 is -2 as well, -1 to -3 is -2. So it's minusing by 2 each time. Therefore, it is an arithmetic sequence. So the common difference, show you working out. I know you can see right there that the common difference is going to be -2. But again, let's use the rule. So any term minus the previous. Okay, so I can use any term here. I might use the third, let's go to the fourth and the third term. So T4, take away T3. They haven't been labeled, but that's okay. You guys know what T4 is, the fourth number. Okay, and T3 is the one before it. So that'll be D equals -5 take away -3. Okay, when you do this, or if you do get confused, put this in your calculator because it'll give you the answer of -2. But remember, when you put two negatives together, it becomes a positive. So sorry if that confuses anybody, but it's -5 minus -3, which equals -2. Cool. So that's definitely a arithmetic sequence. Let's look at this one. 1 to 1. Okay, it stayed the same. 1 to 2 went up by 1. Okay, so what's happened here? It's +0, +1, +1, +3 to 5 is going to be +2, and then that's +3. Okay, so obviously the numbers there the common differences aren't the same, so it's not arithmetic. Okay, not an arithmetic sequence. Okay, let's look at this one. 1 to 1.2. Okay, so that would have gone up by 0.2. 1.2 to 1.4, again, gone up by 0.2. And then 1.4 to 1.6, again, going up by 0.2. So the common difference here, okay, any minus the previous. Again, I can use any term. Let's go term 3 and 2. So T3, take away T2. So that'll be 1.4, take away 1.2, which is 0.2, as we've found there. So there's your common difference. 0.2. Okay, next one. So 2 to 4, okay, it's added by 2. 4 to 8 is added by adding 4. 8 to 16, you've added 8. 16 to 32, you've added 16. So you can see that it's not adding by the same amount. Okay, so it's not a arithmetic sequence. Okay, easy. All right, let's go to the next part. This question here is asking us to now find the common difference and the seventh term. So what you'll find with a lot of the questions you'll be doing in this chapter, and there are a lot of questions, unfortunately, but it's to help you understand this, is you'll be asked to do these sort of questions. So find the common difference and then find the seventh number. Okay, so let's find the common difference. Okay, I can go any, take away the previous. Okay, let's go with T5, take away T4. Okay, so that's going to be 16, take away 14.5, which is 1.5. So the common difference is 1.5. It's adding by 1.5 each time. Now we need to find the seventh term. Okay, so we're given here T5, and we know that each time, okay, bear in mind that you're adding 1.5 to get the next number, okay, because that's the common difference. So we're at T5, we need to figure out, in order to get T7, so term number 7, we need to know what T6 is. Okay, so that means we're adding 1.5 each time. Okay, let's work it out. So to get T6, okay, you're adding 1.5 to the previous number. So in this case, it's going to be T5 plus 1.5. So T6 therefore is 16 plus 1.5, and therefore T6 would be equal to 17.5. Okay, so that's what T6 would be. Now T7, which is what we're looking for, therefore is going to be, again, you're adding 1.5. All right, so it's the current term plus 1.5, sorry, the previous term. So for here, previous number is 17.5, and you're adding 1.5. So T7 is going to be T6 plus 1.5. So T7, the seventh number, is going to be 17.5 plus 1.5. So the seventh number is 19. Okay, so there it is. Nice and easy, straightforward. If you forget how to do this and show the working out, please come back to this part of the video. Okay. All right, so what you're going to do now is you're going to be using your calculator to basically find do these questions, more or less. Okay. Now the worksheet that your teacher is going to give you will look like this. Okay, and it's got instructions there. Maybe I might go through one real quick with you so you guys know what to do. So you can actually generate, which means make the first 5 numbers of an arithmetic sequence. Okay, so according to this, actually let's just use this example here. Okay, with what we're doing. So let's get your calculators out if you've got it. Now I should quickly show you how you can generate these numbers just by using your calculator. Okay, so get your calculator out. I can see here that my first number is 10. So on my calculator, what you'll write down first is the number 10, and then you'd press equals, which is 10. Okay. Now, from there, what you would write is you need to write down the common difference. So if the common difference is 1.5 plus 1.5, so you're going to write plus 1.5. So I've already got down my first number, which is 10. Now, if I press enter, it's going to give me my second number, which is 11.5. If I press enter again, it'll give me my next number, 13. Enter again, fourth number, 14.5. Enter once more, 16, which is my fifth. Enter again is T6, and there is T7. Okay, so if you keep pressing enter, what the calculator is doing is it's adding 1.5 each time. And you can write down all the numbers that you need, depending on how many numbers the questions ask you to write. Okay, so what I'd like you to do is complete this sheet, and yeah, you'll have 5 or 10 minutes to complete this. So please pause the video and do the worksheet. Questions are on the next page. All right, students, let's continue on with the notes, and then after that, you guys can start your exercises. So, last example before we get into the exercises, as you will be doing questions in the exercises that are similar to this example. So, for this arithmetic sequence, 3, 7, and 11, okay, what we need to do is 4 things. Write down the next term, okay, so we're going to figure out what is term 4. Show the term positions and the values in the first four tables in a table. Sorry, of the first 4 numbers or first 4 terms in a table. So basically what we need to do is display them into a table and then use that table to plot the graph. And then question D is describe the graph. Okay, so let's do the first one. Write down the next term. In order to do that, we need to first obviously figure out what is the common difference. So let's quickly work that out here. Okay, the common difference is going to be any term minus the previous. So I might go T3, take away T2. So in this case, it's going to be 11 minus 7. So the difference is 4. Okay, so I'm adding by 4 each time. So if I'm looking for the next term, which is term 4, I'm adding 4. I should actually write here positive 4. Okay, so just keep that in mind. Okay, I'm adding 4. So that means for question A, T4 is going to be, according to this, whatever T3 was, plus 4. So T3 plus 4. Okay, and in this case, T3 was 11. So T4 is going to be 11 plus 4, which means the fourth number is 15. Okay, there's that. Okay, part B. Show the term positions and the values of the first 4 terms in a table. So when you talk about putting these numbers in a table, it's talking about a table like this. Okay, where you've got your term numbers and the value for each term. Okay, so just copy this out. This is what your tables should look like. You can think of it as an X and Y table as well. Okay, so on the top, we'll go with the letter N, which denotes what number it is. And then on the bottom, we'll go Tn, which is basically the value for that number. So you've got 4 numbers for now, yeah? So you're gonna write 1, 2, 3, 4. Okay. Then down here on the bottom is the value of those numbers. So the first number, T1, was 3. So write down 3. I'll use green. Second number is 7. Third number was 11. And the fourth number we got here was 15. Okay, there's your table. It's basically the same, or quite similar to how we've just been writing them previously, like this. Okay, where you've got basically here, like a sequence of numbers. Okay, same as this, but just in a nice, more laid out table that's easy to look at. All right, part C is we need to now put this into a graph. So we've got to plot the graph and then describe it. So question C, let's do that. So here's your x-axis. X-axis. Make sure your lines are nice and straight, guys, when you do this. And then your y-axis there. So on my x-axis is the n, and then the x-axis is n. On the y-axis is Tn. Okay. You can see here the first 4 numbers for n. So it's going to be 1 to 4. So you put those numbers down here. 1, 2, 3, 4. And on your y-axis is the numbers 3 to 15. So make sure all those numbers fit. I might just go by 2s. We'll go 2, 4, 6, 8, 10, 12, 14, and that should be fine. Okay, that should be enough. All right, so let's put our numbers in. First number is number 1, 3. So you put on your x and y graph under the 1, 3 right there. So you can see 3 will be right there for the first dot or the first number when we graph this. Second number, number 2, is 7. So 2, 7 will be about here. Okay, next one is 3, 11. So 3 and then go up to 11. And the last number is 4, 15. So we're going to 4 and 15 will be up about over here somewhere. Okay, so I can see here in this graph, okay, that the dots go upwards, okay, and it looks like they make some sort of straight line, or in other words, they are linear. So in terms of describing this, when we describe the graph, okay, describing this, we can say, so there is a, so it goes, you can actually just say the graph goes upwards, upwards. Okay, so tell me which direction it's going. So it's going upwards and it is linear. Okay, and that will suffice as a description for the graph. Awesome. All right, guys, so that's it for this session and for this the tutorial. What I'd like you to do now is do the questions in chapter 8b or exercise 8b. Please note that all of your questions are actually in the notes that have been given to you. Okay, so all the questions that you need to do are in there, and none of all the ones that you don't need to have been taken out. So just complete the questions that are in there, but as it says here, please complete them in your workbooks. Do not do the questions in your notes. Do them in your books. If you have any questions, please message me on Teams. Thank you.